In this video, I'm going to show you how you can find the area of a regular polygon whenever you're just given the length of a side. So first you have to have a good understanding of what the formula represents and what each variable in the formula represents for the area of a regular polygon. So we have A is equal to 1/2 A times P. Well, the capital A here represents the area is equal to 1/2. The lowercase a represents our apothem. The apothem is going to be the distance from the center of your regular polygon to one of the sides at a 90-degree angle. So it's going to be a perpendicular distance here. And then capital P stands for the perimeter. So I'm going to give you this example right here with a pentagon and a side length of 6.5 centimeters. And the reason I chose to do that is because after I do this electronically, I'm going to show you with a video in a little bit more visual type of a representation so you can see where that's coming from. Okay, now I'm going to erase the apothem that I just drew right here because I want to start showing you how we can determine what the apothem is whenever it's not given to you, since we need to know the apothem in order to figure out the area of the polygon. So what you would do is imagine that this pentagon was inside of a circle. And I know that a circle has 360 degrees. So what I want to do is imagine that I'm figuring out this angle right here from my pentagon. So if I create triangles coming off of the pentagon or inside of the pentagon, we have 1, 2, 3, 4, 5 triangles. So if all of these angles, let me do my imaginary circle right here. Think that it's in this circle, okay? So if all of those angles added together is 360, what would it be for just one of those angles? Okay, now I'm going to erase that circle that I made. So if we're looking to figure out what it would be for just one of those, I would divide by 5. So if we divide by 5, we should get 72 degrees. So that means all of these angles are 72 degrees. Okay. So now what I want to do is imagine that we're trying to figure out the apothem, right? Like this distance, this perpendicular distance coming, or the distance coming from the center of our shape, creating a 90-degree angle with one of the sides. So I need to figure out this A is my apothem, okay? So what I'm going to do is I'm going to create, sorry, let me fill this in. We got 72 degrees when we did that. I'm going to create like a zoomed in version of our triangle, just so that we can see better what it is that we're looking at. So imagine that little yellow triangle. I'm zooming in so that we can take a closer look and figure out what we need to do in order to figure out what the apothem would be. So here's my triangle. Okay, 90 degrees. Man, that's going to bother me if it doesn't completely connect. Guys, I'm trying to make a right triangle. Oh my goodness. Okay. All right, that's decent. Okay, here's our 90-degree angle. Okay, what information can I fill in here from my yellow triangle? Well, I know right here is what I'm trying to find, the apothem. And what about the angle? We said that this, the big angle right here, this triangle has this angle right here that's 72. But if I'm only looking at that yellow part, well, because we have this 90-degree angle that's being formed, we're actually bisecting this angle at the top. So what's half of 72? You should get 36 degrees. Okay, so I have 36 degrees, and I know that I'm trying to find the apothem. What else do I know? Well, I know that this is a regular polygon. That means it's equilateral. So this entire distance right here is 6.5 centimeters. So how could I relate this to my yellow triangle? So it turns out that we're going to be bisecting this side right here as well. And to bisect something, that means we're cutting it exactly in half. So what would be half of 6.5? You should get 3.25 centimeters. Okay, now we have enough information to solve for the length of the apothem. So we're going to relate this to our trig functions that we know. So let me write out at the top. I can't choose a color. SOHCAHTOA. SOHCAHTOA. All right. So for SOHCAHTOA here, we're going to be looking in reference to this 36-degree angle that we have. I know that my apothem is going to be the adjacent side, right? So this is my adjacent side. And I know that the 3.25 is going to be the opposite side in reference to that 36 degrees. So which of my trig functions has opposite and adjacent? Tangent. So we're going to use the tangent function here in order to solve for our apothem. So let me write this over to the right-hand side. I know that tangent of 36 degrees is equal to opposite over adjacent, which is the one that I'm solving for. Oops. Okay. So using algebra manipulation, we're going to find that our apothem, is going to be 3.25 divided by tangent of 36. Now I understand that I'm going very slowly and all we're trying to do is find the area of this pentagon. I'm going slowly because I want to make sure we understand where everything is coming from. Okay, use a calculator. Make sure it's in degree mode. You should get an apothem of about let's round it to, we'll do 4.47. And that's going to be centimeters. All right, we have our apothem, which would give us this number in the formula. So here's what I'm going to do. I'm going to erase this in, here we go. I'm going to erase this part and I'm going to substitute the values into my equation. That way I have a little bit more room. And I'm going to erase my trig functions over here. Goodbye, SOHCAHTOA. See you later. Okay, here we go. That looks a little bit less, less overwhelming to look at. Okay, so my apothem is about 4.47. Okay, for the perimeter, what do we know? We know that I have a side length right here of 6.5 centimeters. And I know it's a pentagon, so I'm going to multiply that by 5. And that would give me my perimeter. So 6.5 times 5 is 32.5. So then I'm going to bring everything down. I'm going to multiply that by my apothem. And I don't give myself a lot of space here. So it's going to be half of that. So let me multiply this in my calculator. So 32.5 times 4.47 times 1/2. That is going to give me an area of about 72.64 square centimeters. This is a rounded answer because the apothem that we got when we used tangent was in a rounded. This was rounded as well. So that is what we get as our final answer. So now I'm going to show you a more visual representation of what we were just doing here, because I don't think that people struggle with using the formula. I think more so people struggle with trying to figure out, what is my apothem? What trig function do I use? How can I figure out the angle that I'm using? So let me show you a more visual representation of how to do that. Okay, so here's my pentagon. I put it on a circle so that we can get the idea of where the 360 degrees is coming from. So this is my pentagon. I measured that with a ruler to get 6.5 centimeters. Hopefully the camera isn't going to constantly be zooming in and out and blurring, but we'll see. Okay, so this is a circle. A circle is 360 degrees. And I know that I want to figure out what the apothem would be, which is going to be this distance right here. That's my apothem. Okay, so I want to focus like on this triangle part. And I know that I have 1, 2, 3, 4, 5 parts of this circle. So then if I divide 360 by 5, I'm going to find that one of these would have a measure of 72 degrees. Okay, so I'm going to label that over here because then I can remove these and you can get a better idea of how we're getting the apothem. So this is 72. Oh, my marker is about to die. 72, 72 adds to a sum of 360. Why? Because it's a circle. Okay, I'm not labeling this yet because what do we know it is? 72. But the reason, well, I guess I could. Yeah. Nah. Okay, it's 72. Now, I want to focus in on this triangle part right here because I want to solve for my apothem. So let me go ahead and just focus in on this part. So I'm going to remove this part, right? And now my apothem is going to be, if this is my side length, from here to here, that's my triangle. And I know this angle right here is 72 degrees, but my apothem is gonna want me to focus on this right triangle right here. So, oh, it kind of looks like a boat. Okay, so if this whole angle is 72 degrees, but it's getting bisected, then right here I have 36 degrees. So let me label that as 36 degrees. Okay, so this is my apothem. I know that my total side length is 6.5. So then halfway would be 3.25. So like all the way to here. 3.25 centimeters. So if I fold this in half, that's what I would get if I were to fold that in half. Okay, now from there, we're just going to use trig, okay? So like, let me get my expo marker. There's my reference angle that I'm focusing on of SOHCAHTOA. I would use tangent because I have the opposite, which is the 3.25, and then I have the adjacent, which is my apothem. So tangent of 36 degrees is going to be opposite over adjacent, which is my apothem. And then with algebra, we're going to get where when you manipulate this, we cross multiply, and then we're really just swapping out this denominator with this numerator. So our apothem is going to be 3.25 divided by tangent of 36. Plug that into your calculator. What did we say we get? Like 4. Oh my goodness, I already forgot. I think it's like 4.5 or 4.48, something like that. Once we have our apothem, then it makes everything a lot easier. So once we know that our apothem is I'm just gonna say 4.5 because that's what I remember it close to being. Then we have our apothem. We have our side length, so we could easily solve for the perimeter. So we plug it into our formula, 1/2 the apothem times the perimeter, 1/2 4.5 times 6.5 is only one of the lengths of my pentagon, so I still need to multiply that by 5. And then you're gonna plug that into your calculator. I think this was like 32 point something. Yeah, so I'm not gonna, anyways, I didn't put all of that. I don't remember it right now because it was on the first part of the video. But I do know that it ended up being about, let's see, hold on. All right, so here, sorry, I'm coming back. Where were we? Okay, so this was, like, I think it was 32.5. Anyway, so then we come back and then total we get about 72 point something, and then it's centimeters. So since we're talking about area, that's square centimeters. All right, I hope this visual was helpful. So if you remember that, think about it being in a circle and we want to find that angle. So you're dividing 360 divided by however many triangles we have here. And since it's a pentagon, there's 5 triangles. So then once we do that, we get 72 degrees, but we have to cut it in half to get the 36-degree angle. All right, guys, I hope that was helpful. Have a great day.